Okay, so what do we call these numbers that you just did right now? So that 1 squared gives you 1, 2 squared gives you 4, 3 squared gives you 9. So that 1, 4, 9, 16, 25, 36, what do we call these numbers? They're called squared numbers. Okay? They're numbers. So a number is a square or is a perfect square. So they're called perfect square. And the reason why they're called perfect square is because if you actually go ahead on your calculator and square root 36 for me, what do you get? Square root 36. 6. Square root, what was another number on your square root 64? It's going to give you 8. Square root 100? 10. So these numbers that you see, the 1, 4, 9, 16, 25, 36, 49, 64, they're called perfect square because when you square root them, they're going to give you a whole number. Okay? So if I take 81 and I square root 81, it's 9. Right? However, would, let's say, 102 be a squared number? No, because square root 102 for me, what do you get? If you square root 102, what do you get? 10.09. Okay, right? So this is not a whole number, so 102 is not squared. Okay? It is very important to realize which numbers are squared numbers because we're going to need them for the next factoring. Okay? So, not only the numbers, they can be squared, also they can be squared. Okay? So, how do you know which letter is a squared letter? If that letter has an even exponent. So, x to the power of 6. Is that a squared letter? Yes, it is. Right? Because it has an even exponent. So it's a squared letter. Okay? Is x to the power of 10 a squared letter? Yes, it is. Now, how can I take the square root of these letters? So if I ask you, what is the square root of x to the power of 10? The answer is going to be x to the power of 5. Okay? So what you do, you actually take the exponent and you divide it by 2. And that is going to be x to the power of 5. So anytime you're square rooting a letter, you divide the exponent by 2. And that's why we want them to be even exponent, because then they're divisible by 2. Otherwise, they won't be, right? So if, let's say if I had x to the power of 5, is x to the power of 5 a squared term? No. 5 is an odd number. If I come to divide this by 2, right, it's going to give me 2.5, which, no. It's not a square term. Okay? All right. Now, why are we doing this? Why is this important to us? Why are square terms important to us? Because we have a special case for factoring. And that special case for factoring, it's called difference of squares. That term is very important, and you should be able to identify difference of squares. Now, before we start, let's define these words. What does the word difference mean in math? When I say difference, I mean difference means, what's the difference between two people's age? What do you do to find that difference? You subtract. So difference means subtract. Difference means minus, right? Squares mean a square term. It's either one of these numbers that you see on your sheet, like something that's squared, right? So for example, x squared is a square term, x8 is a square term, 9 is a square term, 81 is a square term, like any term that is a square term. Okay? So, if you have two terms that are squared, and there is a minus between them, this is a special case of factoring. It's called difference of squares. Okay? So here's what you have to look for. So first, you're going to have to make sure that you only have binomial, so only two terms. Okay? Then you're going to look at your two terms, and then you're going to check, are my two terms a perfect square? So let's look at the first one. Is 9 a perfect square? Can I square root of 9? What does it give me? 3. Is x squared a perfect square? Yes, because it's an even exponent. Good. Is 16 a perfect square? What's square root of 16? 4. So that means both terms are squared. Yes? You agree with me? Okay. Now the second thing that you have to check for is there a minus between the two terms? Is there a minus? Yes, there is. Now you can say, I'm going to use the difference of squares to factor. Okay? So you must have two squared terms and a minus in between. Are we okay with this? Now the question is, how do I factor this? So here's what you need to do. You're going to create two sets of brackets. Two sets of brackets. One bracket has a plus in the middle and the other has a negative. So plus, minus. Then, square root the first term of the polynomial and place 1 in each bracket in first position. So what's my first term here? My first term is 9x squared. When I square root 9x squared, what do I get? 3x, right? Remember that you square root the number, and then this one you divide it by 2. You divide the exponent by 2, right? 2 divided by 2 gives me 1. Good. So I'm going to put 3x in the first position of each bracket. Then I still have the second position, right? For the second position, I have to take the square root of the second term. So my second term is 16. With the square root of 16, what do I get? 4. So I'm going to place 4. Oops, don't place here. 1 second. So I'm going to, you guys are not going to rewrite all of this. But this is my steps to show you. Okay, so you guys are going to go right away to this part of the solution. I'm just showing you basically what you need to do in your head. Okay, in your head, you're going to create two brackets plus and minus in between. In your head, you're going to do the square root of the first term. You're going to put it in the first position, right? In your head, you're going to do the square root of 16. You're going to put it in the second position. Okay? And that will be your factor. So that means this is the standard form. Right here is the standard form. Right here, this one right here, is your factored form. I just factored using a process called difference of squares. All right, so I want to hear your thoughts. What do I have to think about? So when I look at something and the question is asking you to factor, what do you always ask yourself first? Before you ask if it's a perfect square, do I have a common factor? This is always what you're gonna have to ask yourself. No matter what kind of factoring you're doing, always you're gonna ask yourself, do I have a common factor? Okay? Is there anything common between these two terms? No. There's no number, no letter, nothing. Good. The second question you're gonna start asking yourself, is it a binomial or a trinomial? So do you have two terms or three? Two terms. So that could be difference of squares. Okay? Because two terms means binomial. Good. Are my two terms perfect square? Yes. Is x squared a perfect square? Is 25 a perfect square? Good. Is there a minus between them? Good. What formula am I going to use? The difference of squares. So my process is, I'm going to put two brackets. What will I put in the middle? Plus, minus. Does it matter which order? No, it does not, by the way. Okay, I get that question all the time. Doesn't matter if I put minus first and then plus, it doesn't. Now, what's the square root of x squared? X. So I'm going to put x. What's the square root of 25? 5. I'm going to put 5. And done, it's factored. Okay? Now, I want you guys to go back to your homework from yesterday, please. Go back to your homework from yesterday for a second. Did you end up with any of the questions with two terms? The homework. So the homework on page 2. Was any of your answers a binomial? Two terms. Which one? G. C, no. How about B? How about B? What did you get for B? What do you guys get for B? Page 2.
X squared minus 9.
X squared minus 9, right? What was your question? What was the thing? X minus 3. X plus 3. Huh? Same letter, same number, minus and plus. What was your answer again? X squared minus 9. Look here. X squared is a squared term. 9 is a perfect square. And there is a minus in between them. This is their factor. X minus 3, x plus 3. Guess what? You did this yesterday, but you did it from here to here. Today, we are going from here to here. Can you identify another one from your homework yesterday that was like this? D. No. M? Where is it? Right here? Yes. Yeah. M. What did you have? So x plus 5, was it? And x minus 5. What was your answer? X squared minus 25. We just did that, didn't we? Yeah, but we did it backward, right? Here's where you want to put the connection. Okay? All right. So, process. Talk to me. Tell me what you're thinking right now. What are the questions that you're asking yourself? Do I have a common factor? Anyone? Do I have a common factor between these two terms? 16x squared minus 1y squared? Is there any letter that's common? Any number that's common? No. Good. So I don't have to do common factoring. Good. Because always I have to do common factoring first. Second question. What would be the second question that you're going to ask yourself? Is it a binomial or a trinomial? Binomial. Bi. binomial, right? Because tomorrow we're going to learn the trinomial thing. Okay? So is it a binomial or a trinomial? It's a binomial. Good. Are they perfect squares? So let's look at 16x squared. Is it a perfect square? Yes, 16 is a perfect square. X squared is a perfect square. How about 1y squared? It is. If you look at 1 squared is 1, y squared is a perfect square. Good. Is there a minus between them? Yes. Okay, so what would be my answer for this? 4 x plus 1. 4. You don't have to think. 1y, that's right. Yeah.
Is it 1y?
Yes, it is. You guys are correct. See?
So I couldn't just put 1?
You can put y. Okay? So this is what I'm going to do. Try C. I'm going to turn off that video.